Hello, everyone. Today we're going to look at day 17 lecture notes. Hopefully this is like a little bit shorter because it's a continuation from what we've been learning the last couple classes. Okay, so I'm going to share my screen with you. We can look through the notes before we get started on Minitab. So here we can see on today's notes, we're looking at the complete randomized block design. So what this is an ANOVA test. So we're still looking at multiple numerical analysis, right? So means across multiple populations, not just one or two. In the block design, what that does is it allows me to take my ANOVA and add like a second factor, and we're almost going to pair them. So you can see here on the first page of the notes, I talk about the two sample and the paired t-test, and then we look at the one-way ANOVA, and then we're looking at the one-way ANOVA with a block variable. So it's very similar to the paired t-test, but now I'm looking at multiple samples, not just two. So for today's example, we're looking at grocery bills and across 3 different stores. So the stores are my factor, and I want to know if the average price of my bills is different for my 3 different stores. So what we're doing is we're going to add this blocking variable, and what this is, it's something we're not interested in, but it's going to help explain some of the variability in my model, and hopefully enough to make it so it shows what's really going on. And so it should make it a better model. So here with this grocery store example that we're going to look at, what we're looking at is the items. So we're kind of pairing the data by item across all the data. So what I'm talking about is if we're picking up seven different items across these stores, then maybe eggs is one of the items, right? And maybe laundry detergent is another item. So obviously there's a big price difference between laundry detergent, which is like 20 bucks, and eggs, which is like $1.50. So what I want to do is I want to compare the eggs to the eggs for each store, okay? And that's what the blocking variable is going to do. So this first page just explains a little bit about that. When we're looking at these models, we have what we call explained variability and unexplained variability. The explained variability is that variability from my factor, okay, so we call that explained, and the unexplained is the error, okay, and that's the denominator of my F-test statistic. When I add those two, I get my total variability. Now I want you to understand that the total variability for my model will not change. Even when I add a blocking variable, my variability is going to move around from unexplained to explained, but it will not change the total variability. You can even test that out if you run an ANOVA, just a single ANOVA without the blocking variable. And then if you run it with the blocking variable, you'll see that the total variability is the same for the two, but it's just what is explained and what's unexplained has changed. And that's a good thing. So that means we have a better model. We're still going to study the F-test statistic and my p-value in the top row of my ANOVA output. Okay, so this page just goes over that a little bit. We're going to get to the Minitab stuff in just a few minutes when we look at an example. The few differences here when I am running my test, obviously in Minitab I'm going to add another factor, so that will be a difference. But when I'm writing up my ANOVA test with a blocking variable, my goal will be a little different. I'm just going to mention that I have a blocking variable in there, and then that makes my conclusion a little different. So those are going to be some of the differences there, and you can see the conclusion right here. We're going to say after adjusting for the differences in my blocking variable, then we can go on with the same conclusion. So this is going to be the first test that we have that the conclusion is different from what we normally do, which is kind of strange, right? We normally have the same conclusion all the time. This one's a little different. I just have to add that little bit in there. When I'm running my Tukey's or looking at my equivariance or my NPP, I am not going to include the blocking variable. The blocking variable is just something to help explain some of that error and some of that variability, it's not something I'm actually interested in, okay? So I will show you that when we get to our example here, okay? So this first example is the grocery store example, and we're looking at these 7 items for 3 different stores, okay? So of course over here the chart on the left is really nice. We can look at it, we can compare, but that's not how Minitab needs it. Minitab needs it like the data is over here on the right chart. So that's how I have it. So I'm going to go ahead and open up my data from Minitab, and I just have to get to it because I do not have that up front. So let me get that. I'm going to open up in Minitab. So go ahead and do the same. It's the grocery store data, and I want to get that into Minitab so we can do a couple things. So the first thing we're asked, and I will share my screen once I have it pulled up. The first thing we're asked to do is run some descriptive statistics, right? That's the same as always, and I'm just not going to include the blocking variable. So I'm not going to include it there. I'm not going to include it in my box plots either, because it's just something to help explain that variability. It's not actually something I'm interested in. Like, I don't actually care what the item is, right? I just want to know if the average price is different across the different grocery stores. Okay. So sorry, this is taking me a minute to get this downloaded. I was not prepared for some reason for my Minitab. I normally get this done ahead of time. All right, so I have to switch my screens here, so just give me a second to do that. That didn't do what I wanted it to do. Just a second here. Let's see. Having some technical issues. There we go. Okay, there's my Minitab. So we can see that the first column is the store A, B, and C. The second column is the item, and then the third is the price. Now, you need to make sure you can recognize what variable is my numerical variable and which one is my factor. So my numerical variable is my price. My factor is the store. The item is that blocking variable. So let's go ahead and do a couple things. So I'm going to run some descriptive statistics, as we usually do. I always get off that. So I'm going to look at price by store. I'm leaving item out of this, okay? That's not what I'm interested in. Remember, I have my sample means here in my output. That's what I'm interested in for my ranked means, right? So we can see it looks like it's going to be C, B, A, because I'll rank smallest to largest. Now I'm going to take a look at some box plots. Or we could do a couple of things with these. I'm going to go with groups, right? So I'm going to break it out with groups. I'm going to look at price, and I'm going to break it out by store. I'm going to add for my data view to look at my mean symbol, maybe here. So let me click on it. I'll bring that up. For some reason, this takes a minute on my computer. Okay, so there it is. So we can look at this graph. We can see that that store C has a lower average, which we already saw with the numbers. Now, if I ask you to talk about the means or the spread, you could talk about whichever one you want, right? You don't have to talk about everything, just point out something that stands out to you. So here I might say, oh, it looks like store C has a lower average price, but store A looks like it has the largest spread. So that's just something I would mention. You could talk about any of those things that you want. So let's go ahead and build our model. So I'll go to Stat, ANOVA, my general linear model. I'm going to fit my model. So this is going to be a little bit different from last class. So here I'm going to bring in my numerical variable, which is my price. Down my factors, I will bring in my true factor, which means my store. Then I'm going to bring in my blocking variable right after that, which is the item. So remember here, I don't have to do anything else. I could just go ahead and move forward, but I can ask for those standardized residuals for my NPP if I wanted that. So I'm going to ask for that. Just kind of think ahead a little bit. Click that and click OK. And now I can go ahead and OK. Remember, the ANOVA is really the part of the output that I'm interested in. It's like the third box down here. So right here it is. So we can see in the first line for the store, the factor, my F-test statistic is 22.85 with a very small p-value. 0.000, you know it's not really zero, it's just very small. So that is what I'm going to report. In the typed notes, you will see for item, it looks like I've crossed it out because I want you to realize you're not reporting that because it's not actually what we're interested in, because this is still just a single factor with a blocking variable. Okay. So there's that information. Let's just run a couple other things while I'm still on this screen, like our requirements and two keys. The reason why I'm going to run two keys is because my p-value is less than 0.05, so I'm rejecting my null. So I am showing that there's a difference, and my two keys will tell me what is different. So let's check the normality and equal variances first. So I'm going to go to stat, back to ANOVA, and I'm going to check for my equal variance. So that's right here. It's the fourth from the bottom, test for equal variance. I'm leaving my model as is. I'm not going to change my model. My response is my price. My factor is store. I do not add in the blocking variable here. I could just click OK. I don't need to get anything fancy. Remember here, I'm just looking for that test output. Like the third one down here, I'm looking at the last line, which is Levine's. So 0.839 is greater than 0.05, so that means I do have equal variance or constant variability. Okay, good. So now I'm going to look at my NPP. So go to graph, probability plot. So I'm going to just look at the single because I did get the output for my standard residuals. So I'm going to click OK, use standardized residuals in here, and just click OK again. And this way I'm only studying one p-value. If you wanted to do it the other way, you just go to multiple and then you do price. Okay, and then you would divide it out by store. Again, you do not need to put item in here. You don't want to do that. So here my p-value is 0.886. That is greater than 0.05. So therefore I can assume normality here. So good, we've met both requirements. Now I'm going to look at my two keys because we did reject the null. So I want to take that next step to see what is different or what's the same. So I'm going to go to stat ANOVA. And I'll go back to my general linear model. My model's already been fit. I'm not going to change it, but now I'm going to look at the comparisons. So right below that, fit the model. So here for comparisons, I just want to make sure that my price is my response. It should be because I haven't changed my model, right? So my model's fed right from this, or this is fed right from my model. Two keys is what I'm looking at here. I'm only going to check the box of the factor, which is store. Okay, I am not going to include item here. Remember my results, I want to get tests and confidence intervals. I don't need this top one, but if you leave it in, it's not a big deal. Okay, click OK. We can look at the write-up here in just a second. But here's my output. Remember when I'm looking at two keys, what I'm going to do is I can either look at my CI or I can look at the p-value. So if I'm looking at the CI, remember I'm looking for a negative to a positive, which means my CI includes 0. So that means I have that they're the same because I'm subtracting them. That when I subtract them, it's 0. It means they're the same. Or I can use the p-value approach, which means if my p-value is greater than 0.05, then those two are the same. So what that means for my my graphical representation, so those ranked means, I'm going to underline the ones that are the same. So that's B and A are the same. You don't need to do both, CI and p-value. Just use one. They will both give you the same results. So I'm going to go back to the write-up here, like the type notes, so we can see what the write-up looks like. So remember so this is the first part, which I think we probably all have by now. Remember, this is a shorter test process. I'm going to talk about my variable, which is price. My factor is the store. My block variable is the item. I'm going to include that here. Now my goal, I'm going to see if the store has an effect on the price after adjusting for differences in items. Okay, so right there, something different as well. My method, my null is that all the means are the same. My HA is that at least one is different. My sample, here I have my output and I've checked my requirements. So you could see all that right up. That's what we just did on main tab. Okay, so my conclusion here is something new. After adjusting for differences in items at the 5% level of significance, the sample does provide sufficient evidence to say the store has an effect on price. Okay, and then you can see the two keys and the conclusion I have there, my two keys. Okay, so I will see you guys in a minute.